In this video, we're going to take a look at the continuation of number 4 for activity 216, step-by-step truss calculations. With this, we have gone through in steps 1 through 4. We've created a free body diagram identifying all the forces on the entire truss structure. And we have now, with the steps 2, 3, and 4, we have calculated what are the support reactions that we're getting, or how strong do the supports have to be able to be, how much force do they have to be able to support if we put 50 pounds of force all the way out here at the end on joint C as we go along. Okay, so there's joint C. What we're going to move into next is called method of the joints. So we may be moving back up here to this top page, but I've sectioned off the paper. I usually like to do that down here at the bottom because of, kind of separating out what are our support reactions, which are noted by steps 2 through 4. And then this next section is going to be our step 5, which is where we're actually going to be getting into individual truss member forces. So step 5 is called method of the joints, or I just kind of abbreviate it down to method of joints. And what we have to take a look at with our truss structure is we need to take a look at, we've got 3 joints in this truss structure. We're going to identify a joint to start with, to start going through and doing some calculations. Now, the one thing that we want to keep in mind, we probably want to look at joints that have the fewest kind of forces acting on them. So here B has got a lot of forces acting on them. It's got one here, one here. The truss members are actually going to be, we're going to assume that the joints are experiencing tension, meaning that the truss forces or the truss members are actually pulling on the trusses. So you're going to see the arrows are going to be pointing away from the joints. And same thing here. So we've got 4 forces B is operating with. A has 1, 2, 3. C has 1, 2, 3. So really we could go with A or C. I'm going to go with C because this one has the best kind of learning involved, because we do have a vector that is involved, and we're going to have to do a little breakdown. So here's how I kind of handle that. We're going to analyze joint C. Okay, with joint C, I'm going to draw a free body diagram for joint C, and we're going to take a look at what are the forces that are acting on it. So at an angle here, joint C is what we have. This is going to represent the truss member acting at the angle. We've got another truss member acting in the straight line X to the left here, going over to joint A. And then we also have 50 pounds acting downward. So those are our 3 forces that we have acting. Now, our next component would be, we need to look at, do we have any vectors? So in this case, we do have a vector. We have a force that's acting at an angle. We do know what that angle is, but let's go ahead. I like to kind of create a little side calculation here to break down this vector. So here's joint C. Here is our vector going to B, and I'm going to break this down into its X and Y components. So in order to make that happen, I'm going to go over along the left side, and then I'm going to go up on the Y. And here, this is going to be known as CBY, so the Y component for CB, and this is going to be known as CBX, the X component for CB. And then I'm going to note that that's 45 degrees, which we solved for up here in our free body diagram that we had up above. So here is our vector, and with that we need to go through and make some changes as far as how do we go through and break this down. So we're going to need some information from this vector and to account for the forces that are coming from it in the X and Y directions. Usually what I like to do is I'm going to label CBX and CBY, and I want to try to solve for what those are. So right now, if I take a look from my angle, if I solve for CBX, this is the adjacent side of the triangle. So I want to use, and I'm looking for with the hypotenuse in mind. And all of these we're going to be using sine and cosine to find for our force vectors involving our truss members. So in this case, this is the adjacent side, which is going to mean we're going to use cosine. And that's found by taking the adjacent side divided by the hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. I'm going to substitute in what I know. Cosine of 45 is equal to CBX over CB. CBX being the adjacent side, CB being the hypotenuse. And I'm going to rearrange this in terms of CBX. So I'm going to multiply times CB on each side. And CBX is going to be equal to the cosine of 45 times CB. And right now I've got two unknowns in this equation, so I'm not able to solve for anything. This will come up later as we go along. All right, I'm going to do the same thing with CBY. Now CBY is the opposite side of the triangle, which means we're going to use sine. And like I said, we're going to go through and use sine and cosine. However, if you use cosine for one, you're going to use sine for the other. Sine is the opposite side over the hypotenuse. I substitute in what I know. CBY, you're going to see a very similar method here. And in order to get this by itself, I'm going to multiply by CB. So then CBY is going to be equal to the sine of 45 times CB. So they're going to be very similar in their layout. So we get them all on the same line. CBX is on one side of the equation. CBY is on one side by itself, and we're able to go through and start looking at what forces do we have acting in the X and Y direction. So I'm going to go ahead and use the bottom of my sheet here to do that. I'm going to start first, sum of the forces in the Y direction, add up to equal 0. Here, I'm going to look at what arrows do I have moving in straight line Y. So I've got a negative 50 pounds, and then I got CBY acting. So CBY plus a negative 50 pounds. So this is negative because it's moving downward. So moving downward, so that's why it's negative. And now when I add those together, it's going to equal 0. Those are the only two Y direction forces I have going on. Now CBY, I'm not really concerned about what CBY is necessarily. I want to find out what CB is. I'm looking for that truss member. So I'm going to do a little substitution. I know CBY is equal to the sine of 45 times CB. So I'm going to grab this and I'm going to substitute it in for CBY. Sine of 45 times CB plus a negative 50 pounds is equal to 0. And I'm going to do a little bit of arrangement, so I'm going to add 50 pounds to each side. So that'll cancel. The sine of 45 times CB is equal to 50 pounds. Divided by, in order to get CB by itself, I got to divide by the sine of 45. And when I do so, 50 divided by the sine of 45. Here in our problem, they want us to go to precision to 1 decimal place or to the tenths place. So here we're going to look at 70.7 pounds of force. And since that number is positive, that means this truss member is experiencing tension. So that means that truss member, CB, is being pulled apart as opposed to being squeezed in compression. So we know what type of force that this one is actually going through and being experienced. Okay, so the next one, sum of the forces in the X direction, add up to equal 0. So anytime we solve for utilizing the method of the joints, we should be able to get two truss members from our calculations. So as I take a look, I'm going to see I got CB and I've got CA. Now here's the best part, is I'm going to look at CA is moving over to the left. So I got a negative CA. Now I don't have to break that down because it's moving in straight line X. The only time you have to break down vectors like this is anytime that you go through and have a force vector acting in an angle. If it's straight line, we don't have to worry about it. And then I've got a CBX moving to the left. So I'm going to do a plus, a negative CBX. Those are the only two forces that I have, and I'm going to start to look at what I'm going to do here. Negative CA plus, now CBX is equal to the cosine of 45 CB. Very similar like how we did on down here to substitute that in. We're going to do the exact same thing here. So plus, this is going to be a negative cosine 45 times CB, which is equal to 0. And then what I can do is I can do another substitution to solve for CA, which is going to be negative cosine of 45 times, and I already know that CB is going to be 70.7. And when I add those together, they should add up to equal 0. Okay. From here, I'm just going to do a little bit of rearrange of the equation. I'm going to add CA to both sides, so that way they cancel. Here I'm going to get a negative cosine of 45 times 70.7 is equal to CA. And now if I run this on my calculator, I'm going to keep in mind, I'm just going to do cosine of 45 times 70.7, just keeping in mind that negative side is going to carry. And here I get 49.99, which is going to the next decimal, going to the first decimal place past, is going to go through and take me to a negative 50 pounds is equal to CA. And that means this is in compression. So this truss member is being squeezed as he experiences the 50 pounds of force being pulled down from joint C. So let's go ahead and go back up to our free body diagram and let's label those forces. I might have to go through and label these, especially this one. I might go through and draw a little arrow. 50 pounds, and in parentheses I put compression. So notice I didn't put negative 50. I just go through and note that it's in compression. If it's negative, it means it's in compression for the truss members. If it's positive, it means it's in tension. And then written along the length of this member, 70.7 with T for tension. Okay, last step, we only have one more truss member to solve for. We already got two truss members solved for with joint C. I'm going to go through and take a look at, well, what is my next truss joint that I can use to solve for that. Again, I would stay away from B. B has a lot of forces going on with it. I think I'm going to look at A. A has got three members, three forces acting on that truss joint, and that's what I'm going to go to. So over here I got a little bit of space to the side. I'm going to go ahead and I'm going to do joint A next. And then I'm going to go ahead and I'm going to draw a free body diagram for joint A. Joint A is seeing a truss member. Again, we're assuming anytime we draw a member, we're going to assume that it's in tension. So that means the arrows point away from the joint. We have a joint that is pushing, so arrows point away from the joint for the truss members, I should say, because this one here, the arrow is going to be pointing toward it because this is RAX, which is 50 pounds, because RAX is acting on joint A, pushing on the side of it. Okay, but anytime we're going to do with the truss members, we're going to assume that they're in tension. Okay, here I need to know what AB is. So since that's a y direction force, I'm going to say all this, the sum of the forces in the y direction add up to equal 0. When I do that, I'm going to look at what y direction forces do I have. The only one that I have is AB. So if I say all those forces add up to equal 0, and if that's the only one there, then that must mean that that's equal to 0. So AB is not experiencing any sort of force to go through and have on that. And this finishes out our truss structure. So when I go up here, 0.0 pounds. And here we have now finished our truss calculations for this truss that we have, this 3-member truss. This step, the 5-step process, is going to be what you do for every single truss. You follow the same procedures, and you'll be able to solve any truss that is given to you.